So at this point, I am going to just close up the review of the IBM Q experience, the learning materials. So basically, the feeling that I have is, I'm going to talk about these today. The feeling that I have is that if you take a look at the way this introduction material is organized, it really feels like you start quite good with a really good and solid explanation of the very basics, and then it just ramps up in a way that it just becomes really technical in terms of maybe not so useful for building up intuition at the end of the day. And the Hello Quantum game um, does a far better job at these. So I would really highly recommend that you actually play the Hello Quantum game, the app, and also the actual command line game. Basically, at the end of the day, what you have here is, you know, when it comes to what's left in here. So we have the basic circuit identities, which is kind of helpful if you want to really deep dive into how can you construct certain gates by using other gates that maybe it's not extremely helpful intuitively. But basically you've got this kind of stuff in here where it's like if you apply a Hadamard, an X gate, and a Hadamard, the same like applying a Z gate. What else do you have interesting? How do you swap qubits? What else? How do you make a control knot that, because there's technical limitations, right, in terms of what qubits can you use as a control bits or not. So basically, here you've got a bit of an explanation of how do you change the direction of a control knot, and yeah, it's I think it's a bit it's interesting. It's definitely interesting, but I think it's not really needed to go through that controlled rotations. So it really gets a bit technical here in terms of the mathematics behind this. And at the end of the day, actually, the funny thing is most of the stuff you'll learn implicitly while playing the quantum game, the Hello Quantum game, at an intuitive level, which I think is really interesting because it helped me build really the intuition between, wait a second, a qubit has those kind of dimensions and you can measure it, and then you can shift certainty here and there between different dimensions. And I think that's really the gist of it. That's really what's interesting. I'm actually thinking I might just summarize all that stuff into a kind of intuitive introduction guide myself. But don't get me wrong, the IBMQ experience, I think it's a really good one. It's just for the intuitive programmer or someone who just wants to quickly ramp up when hardware will be available at a bigger scale. I think that's maybe a bit too much, right? It's equivalent of learning the basics of how do you build like ANDs, NOTs, and ORs and XORs with all the other different classical gates, classical operators, etc. So it's good to get the basics, but it's not super necessary, at least not nowadays, where there's a really general understanding. If you're in the computer science type of industry, there's sort of a generic baseline knowledge that already helps you enough. And then there's a couple of other chapters on entanglement, which all honestly, let me just clean that up. I'll be honest with you. This is just too technical, even for my taste. That's basically, I don't fully grasp what they're trying to do here. Aside from then showing that, of course, the simulation is different than the results of a simulation are kind of more perfect than on a real device. But it's basically trying to explain you why why this entanglement is not something that you can. It's essentially different than what you have in the classical world. So in this point here, you see the basically the Bell state. That's like an entanglement where the two qubits always agree or disagree. And then if you go and go to the GHZ, I don't remember whether I've seen the name before or not, but this is just the equivalent, but with 3 qubits. So we have 3 qubits and the 3 always agree. So, and basically, I mean, what does it say here? What did it say? Yeah, I mean, it explains you that, it tries to explain that at the conceptual level. You have 3 independent systems then you make up different measurements, and we're going to clean that up. And yeah, it's not really, again, I think it's helpful if you really want to understand the nitty gritty details. But I think anyone is better off playing the Hello Quantum game first, playing the command line game definitely until the end. That really pays off. And then if you want to know, dive into details, I think that learning material online is helpful. Um, just for the curious mind, if you want to dive into the mathematics, also in terms of the universality and all that stuff. So here you have a bit of more the maths of, what's a standard gate set, sort of a gate set with which you can do all the different operations that you might want. So those is more at the theoretical level. Yeah, and that's basically it. So what I would say in general, sort of closing the review of the IBM Q documentation for the introduction to circuits, is play the game first, play the Hello Quantum game first. Definitely recommend it. Play the command line version. Also, you don't need, like, you can play that on the browser. So, and that's definitely interesting. And then dive into that if you want to know the details. It's just a bit confusing because the first chapter starts really low level and then it gets technical really quickly. But it seems like they're improving that constantly. And so yeah, and what I'll do next, I think that's going to be the most interesting, is going through the textbook algorithms and breaking them down. I think that's definitely more practical, and it's going to maybe help me understand a bit more intuitively how algorithms are built. And if at some point I get lost, then I know I can always go back to this guide and then try to understand the details. So having said that, really kudos for the team that's built that documentation. That's definitely a system that I'm sticking with.